Hello everyone. Let's talk about something called classes and objects in Python. To illustrate what these are, I'm going to create a vending machine class and some vending machine objects. I'm going to call it vending machine. Let's make it blue this time for now. Essentially, in computer science, there is a thing called object-oriented programming, also known as OOP. And really, OOP is a design philosophy. It doesn't let you do anything differently than you couldn't do without objects, but it's an interesting way of encapsulating things to try to represent real world objects. Philosophy. Anyways, basically, in Python, this is accomplished using classes and objects. Now, a class is a blueprint. An object is an instance of that class. So, for example, a blueprint of a house plan isn't the actual house, but it represents what each house looks like. And when you give that blueprint to an engineer or a construction company, then they create the house. They create copies of the house that are all similar, but different in some ways. So this is what object-oriented programming is trying to accomplish. Really just essentially an object is a collection of functions and variables that act upon that object. And we'll see what this means in a second. Let's create a class called vending machine. And classes can have, a couple of things. They can have variables, and they can also have functions. One function you can usually have, it's not required, but pretty much always created, is called the init function, which is the initialization function. Whenever we create an object of the vending machine class, this function is called. Now, self is always required. Self just is always the first argument of, or it should be the first argument of any function you have in a class. And then in the init function, this is where you'll define all the variables upon the creation of the object. For example, self.bottles could be one variable. The self means that the variable, okay, so the self here, this means that the variable bottles belongs to this class. So if we create an object, a vending machine object, that vending machine has a bottles variable, and this variable is persistent even upon the even when the function ends, this variable will persist. To demonstrate that, let's actually create a vending machine object now. To do that, we just create a variable. Let's call it vending1. Now we'll call it drink machine. Just call it something that isn't the same as the name of the class. And we'll set that equal to the class. And just like that, now we have a drink machine object, which is a instance of the vending machine class. And the drink machine has any variable we gave it. So to obtain the number of bottles drink machine has, we use the dot. The dot points to a function or variable within that object. So this, for example, allows us to print how many bottles the drink machine has. Of course, the drink machine always has 20 bottles because that's how much we defined it at initialization. Let's run this program. Here we go. We printed how many bottles the one instance of the vending machine class has. Now, it doesn't have to be 20. let's make it random. Make it between 10 and 20. That's how many bottles our object begins with. Then we don't have to just create one object of the class, we can create many. Let's make a soda machine, another instance or object of the vending machine class. And then let's make another one. How about snack machine? And it will be another instance of the class. Now, if we try to print the number of bottles between these three objects, we'll see it's different. That's because upon the initialization of any one of these objects, self.bottles is set to a random value. Now you have to kind of think of it this way. Self is the variable contained in any, represents a variable contained within any one of these objects. So from the perspective of drink machine, bottles, if you were drink machine, for example, you might say, well, my own bottle count is 20 or 15. If you were the soda machine, so from the perspective of the soda machine has so many bottles, and self dot reflects that. So drink machine has its own bottles variable, soda machine has its own bottles variable, and snack machine has its own bottles variable, and these are totally independent. If we run this, we'll see that all three of them have a different number of bottles because it's random at initialization. But let's return it back to 20. Now, it's not that useful to have a vending machine that only has variables in it. We want to have a few functions that act upon the object. Let's make it so that you can purchase something from any one of our vending machine objects. Self is always the first variable, and like any other function, we can send a variable over. We'll give amount as the first argument other than self. Then, of course, when you purchase something, the number of bottles decreases. So let's have, from the perspective of drink machine, its own bottles variable will decrease by that amount. And let's make another function that allows us to restock the vending machine. Now notice we don't put self dot before the amount variable. That's because amount is a local variable we're sending over. So amount is created based on whatever argument we send to the function. So amount is destroyed at the end of the function, but any variable with self dot is not destroyed upon the end of that function. So to call a function upon an object, we put the variable of the object we created, we put a dot, and instead of putting bottles, which would be a variable, we just put the name of the function with the parentheses, of course. Now, the parentheses only need to contain one argument because we don't need to send self over, that's automatic. Our one argument is the amount. So let's make it so we purchase 5 bottles. Then let's print how many bottles drink machine has. There we go. It started with 15, but we called the purchase function. We sent 5 over, so 5 bottles were sold, and then we printed that variable. Okay, let's try our other function. Let's restock 3 bottles after purchasing 5. And then we'll print how many bottles are remaining. There we go. First 15, then 18, because 3 were added and we restocked the vending machine. So we can see that these functions act upon the individual object we created. Same with the variables. Let's make a function that just gets the number of bottles, so we don't have to keep doing dot bottles. We can return a variable. Now instead of dot bottles, to obtain the number of bottles, we can just do get inventory, and then no arguments are sent over. Then that will return the number of bottles currently saved in that object, and we can print it. Now, of course, this function isn't very useful, but you see the point. Let's make one more function. Let's make it so there are no arguments sent over. Let's just make it so it reports how many bottles are currently in the machine. So we'll have a print statement. And we'll print how many bottles are currently there. So then we don't have to have a print statement in global scope. We can just put drink machine report, and then the print is within that function. So we don't have to keep calling print in global scope. Here we go. We called the function within the object, and it has 15 bottles. We called the function again in get report again within the object, and we have 18 bottles. So we can keep manipulating this object, and we can keep playing with variables. We can make multiple drink machines, and we can just play around with it just like that. Okay, let's keep playing around with classes and objects. Let's make a class that represents a triangle. We'll call the file try.py. We'll import random because we want every triangle object to be a little different from the others. And then we'll define the class as such. We'll call it triangle. Now, of course, the first thing we do is make a init function. This is the function called when you first create the object. Self is always there. Then we put, let's say we want two variables to be sent over and set to some kind of self variable within the triangle. We'll let x and y represent those two arguments. Now we need a base and a height. So let's have self.base equal x and self.height equal y. That's because, of course, triangles have a base and a height. If we know the base and the height, we can calculate the area. So before we do anything else in our triangle class, let's make an object. Let's call it try1. And of course, we just call the class itself with two parentheses. Now, the thing we put into the argument we put into these parentheses are the variables sent into the init function. So if we want our base to be 5 and our height to be 4, we would put 5, 4. Then 5 is copied into x, 4 is copied into y, and then self.base is set to whatever x is, self.height is set to whatever y is. Now we need to do that because x and y are local and are deleted upon the and when the initialization function ends. But anything with self dot is not deleted when the function ends. So this kind of stays within the object. Okay. So from there, what else can we do? Let's make two functions that allow the user to set the base and set the height after the creation of the object. We'll call it setBase. And then we'll just do self.base equal to whatever variable sent over. We'll make another function, setHeight, which does the same thing, allows these variables to change after the creation of the object. So it's not that once you can only update a variable within the initialization function. You can update it in any of the functions. So we'll make these two functions so we can update them sometime afterwards. Maybe we won't even use them, but they're nice to have. Let's make another function called getArea. It doesn't take any arguments. Of course, the area is just half of the base times the height. and we'll return area. So now we have an object down here called try1. Try1 has four functions within it: init, self base, set height, get area. It has two variables saved in it. It has self.base and self.height, right? So try1 has a lot going for it. Let's do try1.getArea. That will return the area. Of course, we have to print it because we're not printing that within the getArea function. Here we go. 5 times 4 divided by 2 is 10. So that is our area of this triangle. Now, we can have many instances or objects of the same class. So let's do try2, and it'll have a different set of parameters to begin with. And we can call the same function upon all of them. So now we'll get 3 different areas when we print this program. So try1 is the first object, has an area of 10, try2 has an area of 8, try3 has an area of 25. Okay, so each of these triangles, have, essentially we're trying to model a triangle object using computer science. So, for example, every triangle has a base and a height, but not every triangle has the same base and height. So that's why we can set those as initialization arguments. Every triangle object should have some way of obtaining the area, so we create a getArea function that returns the area. You can see all of these have the same attributes, same functions, but they're all a little different based on the initialization parameters. Okay, let's make another function. And this will just print all of the info of the current object. Let's have a print statement. Let's print the base using percent formatting. And we'll print the height. And we'll print the area. Now, of course, what's interesting is that we aren't only locked into using variables in these functions. If we want to call getArea from within the object itself, a different function within the object, we just do self dot and then the name of the function. So from the perspective of try1 or try2 or try3, whichever instance we call it on, self dot represents the function that we're currently in, or the object we're currently in. So if we're currently within try1, self dot points to the getArea function of try1. So we can call the function like this. GetArea will just go up to line 14, run this function, return the area, and return back into the print info function back to this line, just like any other function would upon the end of that function. So you may not be familiar with this way of printing out variables in Python, but this is a way of doing it. Essentially, %f takes the variable on the right. So self.base is placed into %f. So when this prints, it's like printing the following. Right? So this is pretty much the same thing. These two lines, line 20 and 21, pretty much do the same thing. I'm just choosing to print this way. The 0.2 represents that I will have 2 decimals past or I'm sorry, I will have two numbers past the decimal point represented. So for example, if I run this program, let's actually call print info upon these objects. Here we go. We called the print info function upon the first object, the second object, and the third triangle object. And you see, instead of printing %f, it prints self.base. Instead of printing %f, it prints self.height, and so on. So essentially, the %f just takes the variable to the right of this % and inputs into the string. You will notice that we have 2 zeros past the decimal point. That's due to the 0.2 we added. So this allows us to kind of modify and have more control of our printing. If we did 5, we would have 5 zeros or 5 numbers past the decimal point, just like such. But anyways, finally, the F here represents that it is a float. So because self.base, self.height, and the return of get area are all floats, we have to put an F. If they were integers, we would put D, but they're floats, so we just keep it F. Anyways, that was a bit of a tangent. It's a different way of printing. Let's get back to the classes themselves. So here we have one class with 3 objects of that class, which is fine, but sometimes you want to have a lot of objects of that same class. So I am going to comment this code out and create a list. And in this list, I want to fill it with these objects. So I'm going to make a loop that goes from 0 to 99. I'm going to have a random height from 1 to 10, a random base from 1 to 10, and then of this list, I'm going to append a new triangle object sending these base and height variables as arguments. So what this is going to do is every time it loops, it creates a new object. So I'm going to end up with 100 triangle objects filling my list of triangles. Before we do that, what happens if instead of printing a variable or calling a function upon an object, I try to print that object? So let's create a new object called try. And instead of printing try.base or try.height, what if we just printed try? What would happen? Well, this would happen. It would tell us we are printing a object of the class triangle. And it's located at this location in memory. Essentially, we are printing a memory address. So an object is actually a memory address, and this memory address points to whatever variables or functions are contained within that object. So quite literally, in computer science, or Python particularly, an object is simply an address in memory. We dereference that address to obtain a variable or a function stored in that segment of memory. So just to put it simply, an object is memory, and the dot, like putting dot base or dot height, or dot set height, or dot get area, a function. These are things stored beginning from the memory address associated with try. So we're quite literally saying, okay, here's the memory address try, go to that memory address and then find that variable or that function and call it. So that's kind of interesting. But an object is simply an address in memory. So if we make another for loop, try to loop through the list of triangles, instead of dereferencing something at that memory address, we'll just print the object. What are we going to get? I meant to put the ith one because we only want to print one object at a time. There we go. We have 100 triangles, which are all 100 memory addresses. We can see the addresses are actually hexadecimal, which is kind of how the computer reads these bytes in memory. And they're all really close to each other. And that's because the memory address tries to put all of these, anything in a list really close in memory. So you'll have a lot of the same numbers here, but then kind of near the end, it changes. So it changes a little bit as we go down because these objects are situated, in a sense, sequentially or right next to each other in memory. So now we have F400, F438. And notice if you actually, if you were to obtain the difference between two of these memory addresses, so if you took this one right here and subtracted it by this one here, you would get 38, which means the size of the triangle object is 38 bytes in hexadecimal. And that's actually the same between all of them. So if you take any two sequential memory addresses, subtract one from the other, you will get a difference of 38. So here we have 30. Below that, we have 68. Again, a difference of 38. So every triangle object, just based on how we built it, has 38 bytes in hexadecimal, which is really interesting. If we were to add a new function or add a new variable, that size would increase and every object would be more bytes in memory. Okay, so that's interesting. So let's do something else here. Let's make it so that we're not printing every triangle, we're printing every third triangle. So the third argument here in the range will skip every 3 triangles. Now, because list of triangles I is a single object, a memory address, we can apply the dot to obtain whatever we want from that single object. So if we're using a list of objects, we use a bracket to obtain one object, and then we use the dot in conjunction with that to then further on obtain whatever functions or variables we want in that single object. So now, here's what we'll do. Let's print the info of every third triangle in our list of triangles. There we go. So we have 33 triangle objects being printed. The first one has the following area, the following statistics. The next one has this many, this base, this height, this area, and so on. So each of them is a little different, but they all have the same attributes: base, height, area, and so on. So this is kind of how we work with objects, and we can create a lot of objects by using a list. And we can initialize them with random variables or really whatever we want. or make it so each of them has the same height and base. Really, it's the possibilities are endless. Okay, well, thanks for watching.